Yesterday's classwork focused on simplifying expressions with roots in them. This time we're looking at adding expressions with roots in them or subtracting. And that's it, just adding or subtracting. And the first thing you have to know is when can you actually take these two expressions and mush them together? Because you can't just do it any old time. So I'm going to talk you through these problems, and we'll start with number one. Look at number one, and notice you have 5 times the cube root of x minus 2 times the cube root of x. With the way that I just highlighted those, do some of you think you know how that will simplify? My variable expression is the cube root of x. Yep, that's it. Or that's part of it. Yeah. So if you notice that your variable piece of the expression is identical, you can think of it as you're undistributing it. I remember that I would always look at it as I just see that these are the same thing. And if this tells me I have 5 of them and I'm taking away 2 of them, that means I have 5 minus 2 of them. I have 3 of them. And I want to make sure to clarify that this 3 is coming from the subtraction of the 5 and the 2 alone. I'm also going to write additionally that you can look at this expression as, and I'm factoring out a common factor. Cube root of x is multiplying to 5, and it is multiplying to 2, and they are subtracting. And if I look at it as a distributive property, that can help. But to do this, you have to have the exact same variable expression. Now let's take a look at number 2. Number 2 doesn't have any variables in it, but it does have roots in it. Let's look at the roots. Those two roots are not the same. You cannot combine that into a single expression without an addition sign. The best you're going to be able to do is you could notice that these are both 4s, and you could go, well, that's factor a 4 out. But what you aren't doing is actually adding. This addition can't be done. You cannot add together roots that are not identical. That's important to be aware of. So those two cannot be added together. The only thing you could possibly do is factor the common 4, but you can't actually do this addition. Like over here, we were able to do the subtraction of the 5 minus 2 when we factored out what was in common. but roots cannot be added together unless they are identical. So number 3, take a look at your roots. They both have 11 under the radical symbol, but they don't have the same index. When a number isn't written in the crease of that radical symbol, we understand that that's meaning 2. So it's looking for a number that multiplies twice. But over here, the index is 3, looking for a number that multiplies 3 times. Because those indexes are not the same, you can't do this subtraction. You can't even factor anything out. 6 and 5 have no common factors. There is absolutely nothing you can do to simplify this. And it's very important for you to know with algebra when you can simplify and when you cannot simplify. And here you cannot. There's nothing you can do more. And it's because the indexes are not the same. And I want to go back to number 2 and point out that the indexes are both the understood 2, but the radicand is not the same. And the radicand, I'm going to go back to your classwork from yesterday and show you. But the radicand is the number that is in the root. The index is the number in the crease. Root expressions can only be added or subtracted if they are identical. And I'm going back over to 2. Let me actually just go to the answers over here. There we go. The index number has to be identical, and the radicand. Those have to be identical in the expressions over the addition subtraction in order to actually do anything. When I come back over to number 1, take a look at number 1 again. In number 1, the index numbers are both 3. The radicand, both of them, the radicand is x. If the index and the radicand are the same over an addition or subtraction, you can combine them and smush them together. So now number 4. In number 1, you had a variable in your root, but number 4, no variable involved. The radicands are both 7. The understood index numbers are not written so that it is the understood 2. If they are identical, then you can look at this as the distributive property. And with both terms over that subtraction, both of them have root 7. And you have 5 of those root 7s, and you're taking away 3 of those root 7s to get 2 of those root 7s. So again, it's really important that you know when you are able to take 2 expressions between addition and subtraction and smush them into one expression, or if you're stuck with an addition or stuck with a subtraction, while you might be able to factor something out, if that index and radicand don't match, you will still have an addition or subtraction. But you can see with numbers 1 and 4 that the final answers do not have addition subtraction left over in them. All right, so next I have a couple of problems for us to work through together, and I'm going to talk you through them. If I can get this thing to stop doing that. There we go. Okay. Now, we need to work on this together. Are you with me? Do you have your classwork out? You've got a pencil, pen? For number 5, you have an addition and a subtraction giving you 3 individual terms. The only way any of those terms can be combined is if you have an identical index with a radicand. Now, right now you don't, but you can simplify these radical expressions. Yesterday, we talked about simplifying the radical expressions. So with these problems, you're actually going to start with what we did yesterday in simplifying. And we'll start with the square root of 18. If I'm going to simplify the square root of 18, I need to find numbers that multiply to make 18. And I need to see if I can find index numbers understood to be 2. I need to find the same number multiplying 2 times to make 18. 18 is even. And maybe you recognize that 9 is a perfect square. Or you break it down further to see that it's 3 times 3. The square root of 18 is equal to an entire square root of 9 brings a 3 out. And then this 2 is not able to have its square root taken nicely, so it's stuck under that radical symbol. And the step I didn't write here was that the square root of 18 is the square root of 9 times 2. I am allowed to split multiplication under a root. And then the square root of 9 is 3, and root 2 is root 2. So I'm going to erase a lot of what I have there in just a moment. I'm going to give you a minute or a few seconds, I should say. And I'm going to rewrite 3 root 2. But I want to get rid of some of the mess here so we can focus on the next one. Okay, I'm erasing. Okay. Next, I'm going to focus on the square root of 8. Can I simplify the square root of 8? The index is 2. So I'm looking for a number that multiplies 2 times within the factors of 8. You might see it already. 8 is 2 times 4. 4 is a perfect square number. It's made up of 2 times 2. So when I'm looking at the square root of 8, I can break it up as 8 is 4 times 2. I am allowed to split multiplication under a root. The square root of 4 is 2. And then I have a leftover 2. Actually, let me. So I just want to point out the 2 that stays under the root. And that's different from the square root of 4, giving me the number 2 right here. So the square root of 8 is the same thing as 2 root 2. And I'm going to write that down. And then I'm going to look at my third square root, the square root of 72. I'm going to erase the work I have. Let me know if you need me to pause. And I'm erasing. So square root of 72 is the last one I need to look at. Let's break down 72. First of all, it's even, so I can divide it by 2. And if you need to, you can use a calculator to find out that 72 is 2 times 36. And perhaps you recognize that 36 is a perfect square number. It is 6 times 6. I can rewrite the square root of 72 as the square root of 36 times 2. I am allowed to break up multiplication under a square root, but I want to make sure to tell you, you cannot split up an addition sign under a square root. Only multiplication and division can be split. So 72 is the same thing as 6 times the square root of 2. That was the first step. We have more. I'm going to erase the extra work, but leave what I have in red. And I'm going to rewrite what I have in red. The first term is 6 times 3 times the square root of 2. Then this plus sign comes down. And I have 4 times 2 root 2. And then this subtraction sign comes down, and I have 3 times 6 root 2. When I am multiplying, I want to make sure to point something out to you because I see errors here a lot of times. Right here, there's an understood multiplication. Parentheses is also an understood multiplication. It's very important that you realize that what's actually right here are 3 things, 3 numbers that are multiplying. You have a 6 times a 3 times a square root 2. Anytime you have 3 numbers multiplying, I'm going to set this aside and I'm going to come back to this because I know the problems that people run into. So listen really carefully, even if you think you know what you're doing, listen. If I wrote down 2 times 3 times 4, how would you multiply those 3 numbers? Because I'm pretty sure that most of you are going to multiply those 3 numbers correctly. So I want you to just take a moment and I want you to figure out what is 2 times 3 times 4. And write down in chat what number you get. Right. You guys know how to do that. And I want to make sure that you see what you are doing, because you do it without thinking about what your process is. You're grabbing two of these numbers, any two. Maybe you grabbed the 2 and the 3, and you went 2 times 3 is 6, and then you multiplied that by 4 to get 24. When three numbers are multiplying, you can only multiply 2 at a time. So over here, you can actually bring together the multiplication of 6 times 3. But you can't bring the 6 times root 2 together. You can't bring the 3 times the root 2 together. You're stuck with two things that are multiplying once you do what you can do. So you can multiply 6 times 3 to get 18. And then that is multiplied to root 2, and that particular piece is as simplified as it can be. Then this addition sign is dropping down. Now look at the second term. And what is the most you can do to simplify just what there is highlighted in blue right there? Tell me what you get for simplifying the blue highlight. You got it. The 4 and the 2 are not underneath a square root. I can multiply those two together to give me 8. But the root 2 factor can't be brought together with the numbers that aren't under a root. The reason I'm going through this slowly is because I've experienced a lot of students in Math 3, when you come across this, will often make particular types of mistakes. So I'm really pointing out the details so that you hopefully don't have those mistakes that I often see. All right, then that subtraction sign drops down, and can you tell me what this simplifies to? What does that simplify to? You got it. You can multiply the 6 and the 3 together. They aren't in a square root, but then you have root 2. At this point, you have simplified your square roots as much as you can. Do you see that they are now the same exact index and radicand? And in fact, you've got 18 root 2 minus 18 root 2. That's convenient. And you end up with 8 times the square root of 2. But ultimately, what you are doing is doing 18 plus 8 minus 18 with root 2 factored out of it. I'm going to go through number 6 with you, And then I have a realization that my alarm just went off for 10 minutes left. And I have more that I need to go over with you. And that's why we need an hour and a half. Desperately, we need an hour and a half, not an hour. But I'll explain how I'm going to deal with it. First, let's look at this. Can the cube root of 24 be simplified? Because I will tell you that right now, I can't add these together. My radicands are 24 and 3. I can't bring that together into one squishy statement. But the first thing is simplifying by looking at the factors of 24. Yes, you can work on the quiz during lunch. And I need to be careful that I give it to you in the next 3 minutes. So 24, maybe what you think is 6 times 4. 6 is 3 times 2, 4 is 2 times 2. If it's cube root, you're looking for 3 of the same number. The cube root of 24 is also the cube root of 3 2's multiplied. And I'm just going to put down that that's 8 times 3. You are allowed to split multiplication under a root. The cube root of 8 is 2. And so we have simplified the square root of 24, or sorry, not the square root, the cube root of 24 is 2 times the cube root of 3. And then I'm adding to that the cube root of 3. So I have 2 cube roots of 3 plus 1 cube root of 3 gives me 3 cube roots of 3. And I'm going to emphasize that you can factor or undistribute out the cube root of 3, which leaves you with that 2 plus 1. Okay, I'm going to leave a note to you on Google Classroom how far you need to get through today's homework, but you're not going to be able to finish it, which means that it's not going to be due tonight. Lucky you.